Hi everyone, welcome to the next video on percentage in this playlist of percentages. So today we're going to study about successive percentage change. As the word successive says, one after the other. So when one percentage change is followed by another percentage change. And we're going to discuss a couple of approaches, not only a single approach, maybe three approaches for the same type of question. So let's see the first, just an example. We're going to learn it through an example and then get to a concept. So if there's an increase of 25% followed by an increase of 20%, what is your net change? Okay. What is the net change in terms of percentage? Now, as I said, we'll be talking about three approaches. The first and the most common approach is to take a value, the original value the original number as a value. Now, over here, because this is 25% and 20%, which is like 25% is 1 by 4 and 20% is 1 by 5. The best number to take will be to multiply the denominators. 4 5s are 20 and any multiple of 20. So you could start with 20 itself, you could start with 100, no problem. 100 is the most commonly taken thing. But the reason I'm explaining not to every time blindly take 100 is because then students start taking 100 even for numbers like 14.28, 12.5 and so on. So over here, if I start, suppose this was the number we are talking about. Suppose if I start as the original number as 20. So what is the first change? There's an increase of 1 by 4. In the previous concept, we have learned when something increases by 1 by 4, it becomes 5 by 4. So value after the first change, let's call it value 1. It will be 5 by 4 of 20. Or you can do 1 by 4 of 20 and add it. It's the same thing. 4 1s are 4 5s are 5 5s are 25. So value 1, that is after the first change, it becomes 25. Value 2 or the final value after the second change will become, it is increasing by 1 by 5. So it will become 6 by 5. Right? For people who don't understand how 1 by 5 is becoming 6 by 5, should have a look at the previous video also. So 6 by 5 of 25, that will be 5 1s are 5 5s are and 6 5s are 30. So that's the final value. Okay. Now, which means originally 20 has now become 30. So what is your net change? So we use the formula for change. Change is, or percentage change is change upon original into 100. So we say it's change upon original into 100. So what is our change? 20 has become 30. So the change is 10. Change is 10 upon original is 20 into 100. That is 1 by 2 into 100, which becomes 50%. This is method number 1, where we started by taking a value. And what value did we take? We just multiplied these denominators. We converted the percentage into a fraction. And when we just took the denominators multiplication and we took that as a number. The second approach to do this question would be completely by fraction. Okay. Here we assume the original number to be either n or 1 or whatever you want to take. Suppose if you assume the original number to be n. What is the first increase? 1 by 4. We have already said when something increases by 1 by 4, it becomes 5 by 4. And second time it is increasing by 1 by 5, which means it will become 6 by 5. Okay, pay attention very carefully to this method. Over here, 5 5 will cut. 2 3s are 2 2s are will cut. So the new number becomes 3 by 2 n. The original number was n. The new number is 3 by 2 n. Now, what is 3 by 2 n? If you convert 3 by 2 a percentage, 3 by 2 into 100. If you convert 3 by 2 a percentage, it will become 3 by 2 into 100. That will become 150%. That means from 100%, something is becoming 150%. And therefore, the net change will be 50%. So that's method number 2. Let's go through this one more time. Here what I've done is basically I've taken n as the original value. Because there's an increase of 1 by 4, I made it 5 by 4. And then there's an increase of 1 by 5. I made it 6 by 5. Solve that to get 3 by 2n. 3 by 2n in terms of percentage. Or for people who don't want to do this step, there's one more approach you could have done over here. Okay, so if I don't want to do this, when something becomes 3 by 2 of itself, when something becomes 3 by 2 of itself, the increase is 1 by 2. From n, if it is becoming 3 by 2, the increase, that is change, is 3 by 2 minus 1, that is 1 by 2. And we should know that 1 by 2 is nothing but 50%. So that's the second approach. And the third approach is a direct formula. Okay, so we've understood two approaches. One where we took a value. This looks like the value method is a pretty good method. You should be learning to use that method a lot more. Even fractions is great. So in fact, all three methods are very good. Different numbers, you can use different methods. So the third method is a formula method. The formula goes something like this. Net change is A% plus B% plus AB by 100%. Now, where I can consider this as A and this as B. Now, what happens when I consider A as 25, so 25%, plus B as 20%, plus A into B, that is 25 into 20. If you do 25 into 20, it is 500 upon 100. So that becomes 5%. And we get directly 25 plus 20, 45, 45 plus 5, 50%. So by all three methods, obviously you're getting the same answer. Now, one more thing which people need to understand over here is that the order does not matter. Whether increment of 25 came first or increment of 20 came first, the order does not matter in any of the methods. Okay, in this method, so nothing will change, only 20 and 25 will get interchange. While suppose if you had taken value and done, suppose if I had taken let the original number n be 20. Suppose there's the increase of 20% first. So increase of 20%, which is 1 by 5. So it is going to become 6 by 5 of 20, value 1. Right? So it will become 24. And then there's an increase of 1 by 4. So it will become 5 by 4. So value 2 will be 5 by 4 of 24. That will become 30. And that's your final value. So 20 is becoming 30. So percentage change is 10 upon 20 into 100, which will be 50%. So whether you change the order, where signs are changed, even there it will not matter. So we'll understand in the next example what will happen if signs are changed. So right now we have done three methods, one with the formula, one with value, and one with fractions. Please go through all of them carefully. Let's take three examples. Increase of 25% followed by a decrease of 20%. What will happen over here? Let's try and use the formula because the numbers are easy. As the numbers will get difficult, I'll try and use different approaches. So right now for this, I'm using this particular formula method. As I said, you could use any of the method. There is no problem. So increase of 25. So that's plus 25 followed by a decrease of 20. That means B is minus 20. So B is minus 20. So AB will become negative 500 upon 100. How did I get negative 500? Because 25 into minus 20 will become negative 500 upon 100. That will become negative 5. So we'll get 25 minus 20 minus 5. 25 minus 20 is 5. 5 minus 5 is 0. So the net change is 0%. That means if I increase by 25 and then decrease by 20, my net change is 0%. Decrease of 25 followed by increase of 20. Numbers are changed. So if I'm using the formula approach, it will be negative 25 plus 20 minus 500 upon 100. So that will become negative 5. So negative 25 plus 20 minus 5. Negative 25 plus 20 is minus 5. Minus 5 minus 5 is minus 10%. So the net change is negative 10%. Last one, both decrease. Now here you have to be slightly careful. Both are decreasing, one by 25% and then again by 20%. So it will be negative 25, negative 20, but this time A into B is negative into negative. It will become positive 500 upon 100, which will become 5. So this will become negative 45. Negative 45 plus 5 will become negative 40%. Right? So I hope you all have got all the three examples and understood them, how to go about it. As I said, you could have done other methods also. So if you want just for one of them, I'll show you another method. Let's say for the last one, I show you one more method. Okay, what happens when there is two decreases? And let's try doing them with values. So if I had to do this one with values, what will I get? This is 1 by 4 and this is 1 by 5. So I can again start with the same thing. Let the original value be 20. Something is decreasing by 1 by 4. So value 1. When something decreases by 1 by 4, it becomes 3 by 4. So value 1 will be 3 by 4 of 20, making it 15. Value 2. There's a decrease of 1 by 5, so it will become 4 by 5. So it will become 4 by 5 of 15. So it is becoming 12. Originally it was 20, now it has become 12. Percentage change. Change upon original. 20 minus 12 change is 8. Upon original is 20 into 100. But remember, this time the change is negative because from 20 it is becoming 12. So the change is negative. 20 ones are 25s are negative 40%. And again, you could have done with fractions also. Suppose same question I'm doing with fraction. Suppose I start with the original number as, ये कट लेना पड़ेगा, screen हिल गया था. Suppose if I start with the original number as n and there's a decrease of 25%, that means it is becoming 3 by 4. And then there's a decrease of 1 by 5. So it is becoming 4 by 5. So 4, 4 cut. So it is becoming 3/5 of n. So from n, that is from 1n, it has become 3/5 of n. Therefore, decrease is 1n minus 3/5 of n, which if you solve becomes 2/5 of n. And percentage decrease, convert this to a percentage, 2/5 to percentage. So 2 by 5 into 100. 5 ones are 5 20s are, so that will become 40%. So whether you write negative or you write decrease, same thing. So different approaches for the same type of question, understanding successive percentage change by three approaches. That is, one is by the formula method, second is using fractions, and third is using values. You can use whatever you want, but I would prefer that you know all three. Okay. Now, let's see the next concept where we are increasing and decreasing by the same percent. Again, you can use any of the approaches, but you can also have a special formula for this. If you are increasing by 20% followed by a decrease, sorry, this should be a decrease of 20%, increase of 20% followed by a decrease of 20%, then there'll be a net change of how much? You can directly apply this formula. There will always be a net decrease. We can try by our regular approaches, but first let me explain with the formula. Net decrease will be, obviously, when I write decrease, I don't write the negative sign, or I can write net change, net percentage change will be negative x square. 20 into 20 is 400 upon 100, that is 4%. Okay. So that's one approach. We could have gone by any of our other approaches. So this is 1 by 5, this is 1 by 5. So we could have also done the value method. That is there's 1 by 5 and 1 by 5, two decreases. And if there's a one increase and one decrease. So I can start with the original number as 25 because 5 5 is 25. First, there's an increase of 1 by 5. So value 1, that is after the first change. Increase of 1 by 5 will make it 6 by 5 of 25. Which will make it 30, right? It has gone up from 25. Value 2, which will be my final value, will be Again 4 by 5. Now there's a decrease of 1 by 5, so it will become 4 by 5, 4 by 5 of 30, which will make it 24. Can you see we had started with 25 and we have reached 24? So net change is -1. So percentage change will be -1 upon original is 25 into 100, which is -4%. Right? So that's how you look at successive percentage change. Let's take some examples. A factory produces 3,600 units of goods in January. Due to maintenance, production level fell by 16.66% in February. In March, the production increased by 25% over the February's level. What was the ratio of the production of Jan to March? Now, finally, the question asked is the final answer is a ratio. Whenever you look at such questions and say, what is the final question asked? The final question, if it is asked in terms of percentage or ratios, this value becomes useless. There is no need to take this value. Why work unnecessarily with a very large value? Okay. So there were two changes. One, there's a fall of 16.66%. 16.66 is 1 by 6 from our list of fractions to percentages or percentage to fraction. This is 1 by 6. And then there's an increase of 25%, which is 1 by 4. What was the ratio of Jan to March? So 6 fours are 24. So we can start Jan production as 24 units because finally everything is in terms asked in ratio. So what will February ka production become? There's a fall of 1 by 6. When something falls by 1 by 6, it will become 5 by 6. So 5 by 6 of 24. So it becomes 20. Then there's a rise of 25%. So March, 25% is 1 by 4. So it will become 5 by 4. So March will become 5 by 4 of 20. That means it becomes 25. So from Jan, which was 24, March has become 25. This time they have not asked percentage change, they have just asked ratio of Jan to March. So 24 upon 25 will be the ratio of Jan to March. If they had asked for percentage change, we could have done that also. What would be percentage change if it was asked for? Change. Change is +1 from 24, it is going to 25. So change is +1 upon original 24 into 100. 100 upon 24, right? It will be slightly more than 4%, approximately 4.16%. Okay. So 100, this is approximately 4.16%. Or because they're asked as a fraction, leave it as a fraction. So important is what is the final question asked. If the final question is not asked in a real value, there's no point doing these bigger numbers. Let's see the next question. A company had 1680 employees. Due to expansion, the workforce increased by 14.28% in the first year. In the following year, automation led to a reduction of 12.5% in the workforce. What is the net change in number of employees after 2 years? They've asked for number of employees. That means real number. That means this number becomes important. 14.28 is 1 by 7 and that's an increase of 1 by 7. And second time there's a decrease of 12.5 which is 1 by 8. So one increase of 1 by 7 and one decrease of 1 by 8. And let's see how this is played around. Now again, I'll teach you two approaches for this question. Okay. 7 8 is 56. You could have started with this number or you could have started with 56. But that number, since it is given, let's start with that. Okay. So year 1, suppose it is 1680. So year 2 will become how much? 8 by 7 of 1680. Just look at this, okay? I'm purposely doing this. 7 2s are 14, 28, 4 to 40. 24 8s are. So 0 will come, 8 for the 32, 3, 1920 is the population after, or is the number of employees after 1 year. What will happen in year 3? It is a decrease of 1 by 8. So it will become 7 by 8. So it will become 7 by 8 of 1920. 8 1s are 8 to the 16. and it again becomes 1680. So what happened? We started with 1680, we got 1680. So what is the net change in number of employees? The net change was 0. How should we have realized this in a better way, or how should we have thought that this was a better, well, there could be a better way of doing it? Here, fractions, the usage of fraction becomes a very good approach. Pay attention how. Whatever was the original number of employees, let's call them as n. First, there's an increase of 1 by 7, which means it will become 8 by 7. Second, there's a decrease of 1 by 8, which means it will become 7 by 8. 7 cuts out, 8 cuts out, and we again get an n. So more or less, this gets offsetted. The 14.28% increase and then the decrease of 12.5% on the larger value makes it come back to the same value. Remember what is happening. First, we are doing 14.28% of a larger value, which is 1680. And then we are doing decrease of 12.5% of a larger value, that is 1920. And hence that again comes back to n only. So therefore, net change is 0. Whether they ask as percentage or whether they ask as a number, net change is 0 over here. Okay, interesting question. Whenever numbers are 14.28 and all such numbers, I will never use a plus b plus ab by 100. Yes, you can use, but not worth it. Okay, let's have a look at the next question. The next question, a lot of people don't understand the logic, so let me explain the logic first. The number of seats in an auditorium is increased by 25%. And the price of a ticket also increased by 20%. What is the percentage increase in the revenue collection? Now, think of yourself as a businessman. How do you calculate revenue collected? When you're looking at revenue, what do you say? If you are the owner of an auditorium. So, jitni bhi seats hai, the number of seats multiplied by price per ticket will be your revenue, right? So now, if the price is increasing by, the number of seats are increasing, say you did some renovation because of which the number of seats increased by 25% and the price of a ticket also increased by 20%. So which means even though these two increments are on different things, but both the things actually impact the revenue. Both the things actually impact the revenue, and therefore we can say the net percentage change in revenue will be nothing but I can use A plus B plus AB by 100%. Why? Because finally both of them impact the revenue. So I can directly use 25 plus 20 plus 500 upon 100, which will be 5. So 45 plus 5 will become 50%. So the revenue will increase by 50%. Good question. Understand it very well. Let's have a look at a couple of more questions. Next one, I want to explain something. So that is why purposely I've taken a question which is already slightly from ratio. So people who have an issue understanding ratios right now can maybe come back to this chapter after they finish the chapter of ratios. Okay. At the beginning of the year, the ratio of employees in sales, tech and operation was in the ratio 765. So sales, tech and operations ka number of employees on this ratio. During the year, the number of sales employee increased by 14.28%. So this number increased by 14.28, which is 1 by 7. This number increased by 16.66%, that is 1 by 6. And this number is increased by 8.33%, which is 1 by 12. Now there's a small issue. 7 is divisible by 7. 6 is divisible by 6, but 5 is not divisible by 12. So what I would start initially only is I would multiply all these numbers by 12. Anyway, they want us to find the percentage change. So numbers don't matter. So I can say let sales be 84. Let tech be 6 12s are 72. And operations be 5 12s are 60. And now we can find each increment and then the percentage increase. So increment in sales ka increment, only the increase I'm finding. Increase is 1 by 7. So 1 by 7 of 84 is 12. Say increment in tech is 1 by 6 of 72, which is also 12. And increase in operations is 1 by 12 of 60, which is 5. So the total increment is 29. My total increment is 29 over a base of how much? What was the original number of employees? 84 plus 72 plus 60. That's 150. 150 plus 60 is 210. 210 plus 6 is, I think, what? Just checking, I'm not making a mistake. Is 216 upon 100, right? 150 plus 60 is 210. 210 plus 6, 216 upon 100. So that will be 4 5s are 4 4s are 425s are. 29 into 25 is 725. 725 upon 54. You can use a calculator. Comes out to be approximately 13.4%. Okay. Now, why could we not use successive percentage change over here? Why could we just not take these three numbers and apply successive percentage change? Well, we can't do that because of one very important rule. The number of employees is not same in each department. Only if the number of employees in each department was same, then we could have applied successive percentage change. Otherwise, we can't. One more rule which I want to explain to everybody is when you're using three numbers ka change, always remember that don't blindly, you can't apply the formula of A plus B. You can apply, basically you can say that I will finish two numbers, get the answer and then apply it with the third number. Don't make the formula of your own and say A plus B plus C plus ABC upon 100. Doesn't work. Remember that very carefully, okay? Let's have a look at the last question. The last question is not so much successive percentage change, but I'm just trying to explain it, a small percentage question by bringing in a small change. Karan's salary increased by 40% and at the same time Arjun's salary decreased by 20% to make the two amounts equal. So let's say Karan's salary was K and Arjun's salary was A. You could take 100K and 100A also. There's nothing wrong. But I just want to teach you fractions. What is 40%? 40% ka increment. Okay. You can make it 40 upon 100, which will be 2 by 5. Or you can make it 1.4. So current salary was K. I'm purposely using different approaches. So the new salary will be 1.4K because increase of 40%, right? And Arjun's salary decreased by 20%. So decrease of 20% will make it 0.8A. Remember, you can also use fractions. If you use fractions, this would be 2 by 5. So increase of 2 by 5 makes it 7 by 5 of A is decrease of 20%, which is 1 by 5, makes it 4 by 5. This was K and 4 by 5 of A. Well, anyway, if you remove the decimals now, you would have got more or less the same thing. What do we want to find? Initially, what percent of Karan is Arjun? We want to keep Karan as a base. Arjun is what percentage of Karan? So Arjun upon Karan is what I want to find. So it will not be 14 upon 8, it will be 8 upon 14. Pay attention very carefully because, it will be, we want to keep K in the base, right? So it will be 14 upon 8. 14 will come here, 8 will come here, and this will be A upon K. So what will we get? 2 4s are, 2 7s are. So initially, what percentage of Karan is Arjun? So we can convert this to a percentage. Answer will be 7 upon 4 into 100, which will make it 175%. Okay, no successive percentage change in this question, but that was just to understand some new question. So we've done enough concepts of this type. I hope you go through this concept really well to understand each and every question well.